Hello everyone, my name is Bindushri. I am studying third semester of Computer Science and Engineering in Sri Venkateshwara College of Engineering, Bangalore. Today in this video, we are going to discuss about the chi-square test. Let me explain about it, and the contents of this are important terms, introduction, characteristics of the test, chi-square distribution, and the last one is applications of the chi-square test. First, the introduction. The chi-square test is an important test among the several tests of significance developed by statistics. It was developed by Carl Person in 1900, and chi-square test is a non-parametric test not based on any assumptions or distributions of any variable. This statistical test follows a specific distribution known as chi-square distribution. In general, the test we use to measure the difference between what is observed and what is expected according to an assumed hypothesis is called chi-square test. And the important terms are parametric test, non-parametric test, and the third one is hypothesis. First, the parametric test, the test in which the population contents like mean, standard deviation, standard error, correlation, coefficient, proportion, etc. and data tend to follow one assumed or established distribution such as normal, binomial, Poisson, etc. And the second important term is non-parametric test, the test in which no constant of a pollution is used. Data do not follow any specific distribution and no assumption are made in this test. Example, to classify good, better and best, we just allocate arbitrary numbers or marks to each category. And the third important term is hypothesis. It is definite statement about the population parameters. And the fourth is null hypothesis. It states that number association exists between the two cross-tabulated variables in the population and therefore the variables are statistically independent. Example, if we want to compare two methods, method A and method B, for its superiority, and if the assumption is that both methods are equally good, then this assumption is called as a null hypothesis. And the fifth important term is alternative hypothesis. In this case, proposes that the two variables are related in the population. If we assume that from two methods, method A is superior than method B, then this assumption is called as a alternative hypothesis. And the sixth term is degree of freedom. It denotes the extent of independence enjoyed by a given set of observed frequencies. Suppose we are given a set of n observed frequencies which are subjected to k independent constraints. And the seventh is consistency table. When the table is prepared by enumeration of qualitative data by entering the actual frequencies, and if the table represents occurrence of two sets of events, the table is called the contingency table. And the next topic is important characteristics of a chi-square test. This test is based on frequencies and not on the parameters like mean and standard deviation. The test is used for testing the hypothesis and not useful for estimation. This test can also be applied to a complex contingency table with several classes and such as is a very useful test in research work. This test is an important non-parametric test as no rigid assumptions are necessary in regard to the type of population, no need of parameter values, and relatively less mathematical details are involved. And here we can see the distribution, and if x1, x2 up to xn are independent normal variate and each is distributed normally with mean 0 and standard deviation unity, then then x12 plus x22 plus up to xn2, it is distributed as a chi-square with a degrees of freedom where n is large. This square curve for is and 9 is as follows. It will follows a degree of freedom to distribution is bell shaped. If the degree of freedom is equals to 2, distribution is L shaped with maximum ordinate at 0. If degree of freedom is greater than 2 or less than 0, distribution L shaped with infinite ordinate at the origin. And applications of a chi-square test. This test can be used in three methods. The first is goodness of fit of distribution. Second application is test of independence of attributes. Third is test of homogeneity. First application, test of goodness of fit of distributions. This test enables us to see how well does the assumed theoretical distribution such as binomial distribution, Poisson distribution or normal distribution fit to be observed data, and where 0 is observed frequency, E expected frequency, and if x2 calculated is smaller than x squared tabulated with n minus 1, then null hypothesis is rejected, otherwise accepted. And if null hypothesis is accepted, then it can be concluded that the given distribution follows theoretical distribution. And the second application is test of independence of attributes. Test enables us to explain whether or not two attributes are associated. For instance, we may be interested in knowing whether a new medicine is effective in controlling fever or not. Test is useful. In such situation, we proceed with the null hypothesis that the two attributes are independent, which means the new medicine is not effective in controlling fever. And x2 at certain level of significance for a given degrees of freedom, the null hypothesis is rejected. For an example, two variables are dependent, is effective in controlling the fever, and if tabulated the null hypothesis is accepted, two variables are independent and effective in controlling the fever. When null hypothesis is rejected, it can be concluded that there is a significant association between the two attributes. The last application is test of homogeneity. This test can also be used to test whether the occurrence of events follow uniformity or not. For an example, the admission of patients in government hospital in all days of a week is uniform or not can be tested with the help of chi-square test. Then the null hypothesis is accepted and it can be concluded that there is a uniformly in the occurrence of the events, uniformly in the admissions of patients throughout the week. Thank you. Thanks for